You've done solving vectors before. You've done it in Pure 1. And I believe vectors comes up in mechanics as well. You've probably done it in mechanics too. So, that being said, can you try the question on the board, please? Okay. PQRS forms a parallelogram. Let us draw a parallelogram. Something like this. I'm going to randomly label PQRS. PQR PQRS. Okay? P and Q are parallel. Sorry, PQ is parallel to SR, and PS is parallel to QR, like this. And we've also got the coordinate of each one. Now, since it's parallel, PQ is equal to RS. Let's do it the other way. QP, sorry. They need to go in the same direction. They're equal, right? So OS is going to be OR plus RS, which is the same as OR plus QP, because we stated here that it's the same. OR has the column vector 8 minus 2, 0. You could have also written it as 8i minus 2j. It's 0k technically, so there's no k. QP would be OP minus OQ. So 4i minus 9j minus 3k minus 7i minus 7j minus 7k. This is equal to minus 3i minus 2j plus 4k. That's the vector QP. Okay? Right. So we said OR plus QP gives OS. OS, therefore, will be 8i minus 2j plus minus 3i minus 2j plus 4k. Like this. Which gives 5i minus 4j plus 4. Or you can write it as 5 minus 4, 4 as a column vector. Whichever one is easier for you. So that means S has the coordinates 5 minus 4, 4. There we go, done. That's the coordinates for coordinates. Sorry, I can't talk. Coordinates of the point S. Cool. Next one. This one is difficult. It's not easy. It's something that you have come across before though. So if you remember, in AS, we did the whole lambda mu thing. That's what you're going to do here. So if you feel comfortable enough, I want you to try this one, please. Okay, it says, prove that the diagonals OE and BG intersect each other. Right, so let's draw OE. I'm going to do it in red, like that. And BG, I'm going to do in blue, there. They intersect at this point. We're going to call that H, because it's the next letter in the alphabet. Okay, so OH can be expressed in two different ways, right? One way is to go part of the way along OE. So let's call it lambda OE. Then the other way to express OH is to go part way along BG. So we go from O to B and then we go part way along BG. So lambda and then mu. Okay? Now, they both equal OH. So they both equal each other. Like this. Cool. How do we express OE in terms of ABC? OE in terms of ABC, we can go from O to B, B to F, F to E. So O to B plus B to F plus F to E. O to B is B, B to F is C because it's parallel to OC, and F to E is A because it's parallel to OA. So A plus B plus C. Cool. OB is just B, and then BG. How would we express BG in terms of ABC? Well, we can go from B to O plus O to A plus A to G. B to O is minus B plus A plus C. So A minus B plus C. Now that we have all the vectors, we can do lambda OE A plus B plus C equals B plus mu A minus B plus C. Okay, now let's expand. Lambda A plus lambda B plus lambda C equals B plus mu A minus mu B plus mu C. Now we can equate the coefficients. So lambda A equals mu A, lambda C equals mu C, and lambda B equals B minus mu B. If we take away all the A's, B's, and C's, we're left with lambda equals mu on two separate occasions, and we're left with lambda equals 1 minus mu. So we have a simultaneous equation here. When we substitute mu equals 1 minus mu, we're left with mu equals a half. And since lambda equals mu, lambda also equals a half. Okay? Since they're equal to a half, that means OH equals a half of OE. So H bisects OE. And BH equals a half of BG. So H bisects BG. There you go. Done. That's it. They said, prove that the diagonals OE and BG bisect each other. If both of them, you have to go halfway along to get to H. And we've proved that OH and BH being along the same path and they reach the same point and you have to go halfway along. There you go. We've proved that they intersect each other. That's it. Vector problems in 3 dimensions.